Hello, welcome back to the ELECTRO-MASTER channel. Today, I'll show you how to repair a Dixell XLR 170 temperature controller step by step. If you want to learn how to identify and fix faults, stick around until the end. I want to mention that it helps me a lot if you subscribe, give a like, leave a comment, and share the video. This motivates me to create even more helpful tutorials for you. I received this device for repair with the issue that the compressor doesn't start. In this video, I'll diagnose the problem, check the components step by step, and try to find the cause of the malfunction. Let's see what's wrong and how we can fix it. I will perform a thorough visual inspection of the electronic board, carefully examining the components to identify any visible defects, such as burn marks, cold solder joints, swollen capacitors, or damaged components. This initial check helps quickly detect hardware issues that might prevent the device from functioning properly. I did not find any visible defects, so I will proceed to identify and check the connection terminals. I will test the power supply to the electronic board, the connections for the room temperature sensor, the evaporator sensor, as well as the compressor and evaporator fan terminals. These steps are essential to determine whether the signals and power reach each component correctly. I will start by identifying the 230V power supply terminals. I will check if voltage is present at the controller input to ensure the device is receiving proper power. This verification is essential to rule out any potential issues related to the power source or electrical connections. So far, everything seems fine, the device powers up correctly. However, it triggers error codes P1 and P2 because the evaporator and room temperature probes are missing or not connected. The next step will be to check and properly connect the sensors to continue the diagnosis. I will connect two incandescent bulbs to simulate the operation of the compressor and the evaporator fan. This method will allow me to check if the control unit correctly sends power signals to these components, effectively simulating the system's behavior under operating conditions. As you can see, the output for the compressor is functional. The control unit successfully sends voltage to the simulated load, indicating that the relay and control circuit are working correctly. This confirms that the compressor signal is being properly activated. I will place the evaporator probe in a piece of ice to simulate the cooling process. The temperature needs to drop to 2 degrees Celsius for the controller to activate the evaporator fan. This test will help verify if the fan output responds correctly to temperature changes. As you can see, the fan control is working properly. The controller sends the power signal, and the fan starts according to the preset settings. This indicates that the control circuit and the corresponding relay are functioning correctly. I will reassemble the device and then test the remaining functions using a digital multimeter to ensure everything is working properly. This final check will confirm that all components are receiving the correct signals and that the system is fully operational. This device is fully functional, and the fault lies elsewhere in the system. It seems the previous technician misdiagnosed the issue. It happens sometimes. Proper diagnosis is crucial to accurately identifying the root cause of the malfunction. Thank you for watching this video. If you found it helpful, don't forget to give it a like, leave a comment, and subscribe to the channel. It helps me a lot to keep creating useful and interesting content. I'll be back soon with more videos on troubleshooting, testing, and technical solutions. Until next time, happy repairing.